Okay, we have this problem that says that solve using separation of variable. Okay, to solve this problem is very simple. We just have to find derivative of u in terms of x and derivative of u in terms of y, and then introduce the new variables and then separate the equation. So let's go. Okay, solution. For the solution, we just have, okay, I'm gonna say u equal to x and y, where x is the x function of x and y is a function of y. Then I have derivative of u in terms of x. Y is gonna be a number, it's gonna be a constant. So I'm gonna have just x prime times y because y is gonna be a number. It's gonna be not a number, it's gonna be a constant. And then I have to find over y. Now x is gonna be a constant. Just have to find the derivative of y because I'm just finding respect to y. Then I'm gonna sub to the equation we are solving. Then I have x dot x prime y equal to x y prime. Okay, now I'm gonna divide both sides by xy. This is gonna give me, I have here xy, and then here I have xy. I'm gonna cancel this and cancel this, then I end up with x prime over x equal to y prime over y. Now, there's the name says using separation of variables. Now that means I need to separate. Okay, to separate, I'm gonna say all of these has to be equal to some constant. I'm gonna say lambda, alpha. I'm gonna say alpha. That means I'm gonna have the first term, the first side has to be equal to alpha. The second side also has to be equal to alpha. It is just the same. Okay, now I just need to integrate. If I integrate both sides, then here I have ln x is gonna be alpha. If I just do the integral alpha x plus c1. Here if I integrate, I'm gonna have ln y equal to alpha y plus c2. Just remember that here I end up with x and y because I have x prime. So I would say dx big X over small x if I had to solve it. So that pretty much would imply I would have d big X over x equal alpha d small x. Integrate, then I would end up just here. So I just did a full step. Okay, then from here, I'm gonna have x equal to e alpha x plus c1. Here I have y equal to e alpha y plus c2. Okay, now what you just now you have x equal some constant cu alpha x and y equal another constant alpha y. That means u is just the product of both y. Then you just have c1 times c2 like that. Then u equal c1 times c2 is gonna be another constant. I'm gonna call just c alpha e alpha x plus y. So this is your solution using separation of variable. So it's very simple. Now another question to solve is 5. 5. Okay, now number 5. Number 5, again we have u, x, and y. Again, you have just x, y is a constant, so you don't find the derivative of that, and then you have delta u over y is a constant, y prime. Now just sub. You have small x times big X prime y equal to small y times big X y prime. I'm gonna divide both sides by x, y. Then I have x, y, and I have x, y. Okay, then here I cancel both sides. Then I have x over x. Then here I have y, small y. And I have, I cancel this. I have over y. Okay, then I just need to separate. To separate, I'm gonna say here I have just side, just x side here, and then just have y variable, so I can just separate alpha. Again, that means I have x over equal to alpha. Then I have, then I have y equal to alpha. Then you have x prime over x equal to alpha over x. Then you have y prime over y equal to alpha over y. As mentioned previously, big X equal to d big X over small x. And then big Y equal d of big Y over small y. Then you have dx over dx times y over big X equal to alpha x. And then you have dy over small y times 1 over y equal to alpha over y. Then you have the big X over x equal to alpha over x times dx. And then you have dy over y equal to alpha y dy. Now integrate both sides. Then you have ln x equal to alpha ln small x plus c1. You have ln y equal to alpha ln y plus c2. Now, now you, let me just see here. You have x equal to e c1 plus alpha ln x. Then you have y equal to e c2 plus alpha ln y. Here gives you just c1 e ln x to the power of alpha, and then here gives you c2 e ln y to the power of alpha. And then ln with e cancel each other, then you just have x is going to be c1 x to the power of alpha, and then y equal to c2, you have y to the power of alpha. Then u is going to be x times y. Then you have c1 x to the alpha times c2 y alpha. Then you have just a constant c x y, all of that to the power of alpha. That's your solution. Now this is another question that we need to also solve using separation of variables. Okay, Now let's deal with that. Now this one, we're gonna use x and t. Yeah, we'll be using x and t. Let me just see. Okay, x and t. We're gonna use x and t. Now we have gives x prime t, because t is gonna be just a constant. Then we have second derivative. We have, and then t, like that. This again, we do the same for time. We end up x t twice, because x is gonna be a constant in this case. Okay, just sub to the equation. You have a squared. The first term is just this. You sub by x equal the second term x, like that. Okay, then I need to, for to separate, I'm gonna divide both sides by xt. Then I have x t, and I have x and then t. Okay, then t cancels and x cancels. So you have a squared, like that, divided by x equal to t twice over t, like that. Okay, now you need to separate. Yeah, usually it doesn't really matter how you do it, but to separate, you can just, okay, you have all the x in one side, and you have all the t's in one side. That means you can separate. You can just separate. I'm gonna say, okay, all of these equal to lambda. That means I have a squared equal to lambda, and now t over t equal to also lambda. Then I have a squared minus lambda x equal to 0, and then I have t minus lambda t equal to 0. And then I have x second derivative minus a squared x equal to 0, and then t second order minus lambda t equal to 0. Okay, now we need to solve for x and t, and these are second order ODEs. To solve for that, usually the solution is going to change depend on lambda. So I'm going to say, okay, case 1, lambda equal to 0. If lambda equal to 0, then I have equal to 0, and I have second derivative equal to 0, because I sub 0 here, and it cancels everything. So here, I just have, okay, if I integrate once the first time, C1, C2. Then if I integrate the second time, I get x, C1x plus C3. You just change, just put a different constant, doesn't matter the order. And then t, you get C2t plus C4. That means your solution, t in this case, is C1x plus C3 times C2t plus C4. But this solution is just for when lambda equal to 0. Now you need to solve, okay. Now let's say case 2. If lambda is positive, I can say, okay, lambda is a positive number, because alpha can be any number. When you square it, you always get a positive. That means lambda is always a positive. So if you have lambda is a positive, then you sub here, then you're gonna have x minus alpha squared a squared to 0. And then you have t second order minus. Just solve these two equations. These two equations you can just solve by finding the characteristic equation. If you remember, if you have, for example, second order minus, I'm gonna solve beta squared equal to 0. When you solve r equal to plus or minus beta, then the solution exponential form would be like something like c1 beta x plus c2, something like that. If you still remember, when you have positive and when you have complex, you go to whatever that is, right? Depending on the values of the characteristic equation. So similarly, we can just solve the characteristic equation r squared because it's second order minus alpha squared a squared. Here there's not any other derivative, right? So there's no r equal to 0. And here you have r squared minus alpha squared equal to 0. Okay, for the one on top, you have r equal to plus or negative alpha a. For the one at the bottom, you get r equal to positive or negative alpha. So you can just write a solution for the one on top. X equal, I use C1, C2, C3, and C4, right? Now I'm going to start for C5. C5 cos hyperbolic of alpha a x is for x, okay, x plus c6 sine hyperbolic of alpha ax. This solution, usually you could also say, you could also use, okay, you could also use that x equal to c5 alpha x over a plus c6 minus alpha x over a. It's also correct, but we are using this because later when we start solving, we're gonna see why it's important to use this instead of this. And now t, if you solve for t, you see that t, this one here also the same. We can also evaluate this one by using t. If you solve for t, we also get the same solution. We have c7 cos hyperbolic of alpha t plus c8 sine hyperbolic of alpha t. Then we get u, x, and t is gonna be c5 hyperbolic cos alpha a x plus c6 hyperbolic sine of alpha a x. This multiplying c7 hyperbolic t plus c8 hyperbolic sine alpha t. Some people they write, usually in the textbook, not some people in the textbook they write like this, hyperbolic. But usually I just keep short, just write like this. Then you also get to go, okay, for case 3, you go if lambda is a negative number. Okay, I'm gonna say lambda is a negative number because alpha squared is always a positive, right? So I put minus on top. Then if I do that, it brings all the way to here, but then I have a positive sign instead. So I have now second derivative plus alpha squared a squared x equal to 0. And then I have y second derivative plus alpha squared y equal to 0. Oh wait, it's not y, it's t. Yeah, it's t. Okay, now here, again, if I solve the characteristic equation, I get r squared plus alpha squared over a squared equal to 0. Then I have a r equal to plus or minus complex, right? Is a complex. And then r, you have r plus alpha squared equal to 0 for t. Then you get r equal to plus or minus alpha I, complex. So for complex, you still remember from ODEs, I can write for the solution for x. Okay, I used already until C8, now I'm going to start from C9. I can say C9 cos of alpha A x plus C10 sine of alpha AX. And then for t, for time, I'm going to do C11 sine, also the same cos. Doesn't matter the order, but I'm going to just keep the order constant. I'm going to just keep the same. Yeah, plus C12 sine of alpha t. Then your solution u is the product, x times t, right? So C9 cos of alpha a x, C10 sine alpha a x times C11 cos alpha t plus C12 sine alpha t. So that's your solution. You actually get, you have solution for lambda equal to 0, which is this. Then you have for lambda positive, which is this. And then you get for lambda negative, which is this. So three of them are the solutions of the equation by separation of variables. Okay, then the next videos we're gonna start actually solving this equation for different boundary conditions. So guys, please watch the next video.